Okay everyone, this is the finalized CAD. I found this to be the most effective way to discuss the details with you guys. I can also send the SLD PRT file. I designed everything in one file, so you gotta kind of distribute the parts on your BIM and the rest. Anyways, so this is the contraptment. There are some variables. Bearing outer diameter, inner diameter, thickness, PVC, outer diameter, length, stepper motor, the outside dimensions, and bolt distance. These are variables, so they can be changed based on if we do happen to have changes. Let's start from here. So this orange part is gonna house this piece together. So this is, I roughly designed the stepper motor, and anytime you see something with that sign, the red one over there, that means it's a variable, and I define what variable that is. So this is right now equals stepper motor outer dimensions. Sometimes it's a formula of different things, which we might come across it. So this is based on, my bad. This is based on what I found online, the link that you guys sent me. So the length, everything, even the length of the shaft also. Even this thickness here is to spec. I'm gonna bring back my piece. Okay, there we go. I cleaned up this area, part of it, instead of the crazy thing they did over there. I didn't really like having it multiple mini pieces, so I kept it as is. Simple, easy, and printable. The most important part is printable because I'm printing it and it has to be compatible. The whole assembly will be in compression the whole time, so these rods, they just friction fit inside. Even if they're loose, the belt that's going across is going to hold everything together. I can add holes to the bottom so you can screw it through the piece and through the tube. I don't see it being necessary, so I ignored that. I still can if you guys want. This is that. Then on the other side, how this is gonna be is there will be two bearings, one on the other side, one on this side. The bearings would sit, the spicks on the bearings are here. So this is 22 on the outside and 8 on the inside. The outside diameter here is 22.8, which the 0.8 is the error margin for my printers that I found. Bearings would be glued over there. There would be no lateral force, so they won't slide in or out. Glue would be more than perfectly fine. Between them, there would be one bolt of, it can be any kind of bolt, M8 or M4. I would rather go M4, which is cheaper, and I'll make the adapter for it. The adapter it sits inside. So the adapter that goes in it would have the outer diameter of 8 and inner diameter of 4 with the error margin, which is my side of the calculation, and that is to adapt all of the bearings we have to the M4 bolts that we got to make it affordable. This is that. So two bearings, one rod in the middle, and to the bolt, this is gonna get attached. Let me see. Either this guy, these guys, or those guys, doesn't matter. And there will be a full belt going across it. Probably the most important part of the whole thing is the belt being not only parallel to itself the whole time, but also horizontal, which this is how you can see. So I'm going to hide that piece for now. Over here, the 23.5 is from the inner circle. Okay, let's go here. Inner circle to the top surface here. Same would be for these guys. There are different size shafts and bearings, but the distance is the same. And on the inside, the top of each roller, each pulley would align perfectly. That's what I made sure to be the case. Also, looking from that view, so this is the stepper motor. This is the promoter shaft. This is the plate that's on the roller. This is what this is. And when belt goes over this, which would be located somewhere in this area, the cross section of the belt would be around here. It's 6 millimeters wide, 3 thick. It goes from motor to the sliding piece. I call it this thing roller, doesn't matter. It goes from underneath and out, and when the end of the belt is sticking out, it will be clamped by these guys. That's how to do it. Then okay, the whole thing will be connected together. That's how it is. So, and the most daunting part, I guess, is this middle section. All these slits are adjustable, so you can obviously, I mean, it's obvious how it is, just you can move in and out. These holes are for the belts. And I mean, there's one belt. These guys, okay, what I did, let me cut a cross section here. These 3 rectangles that you see is pulley that is going to hold the rolling contraption on the rods. These are not held anywhere right now, these are movable, but I made them tangent to the rod and to kind of roughly get the angle and everything else. The holes, on the other hand, are very perfectly calculated, being actually it is worth it to show you guys. When I was talking about the, okay, here. Where are the holes? Okay, there we go. So when I was talking about the equations and the variables and all that, this is what I meant. Going through here. So the distance, so how tall, how far up these bolt holes are determined by the pulley. I designed the pulley over here just to have a reference. This dimension is from the middle of it till the end of the PVC tubes that we have. So the distance is full diameter of the PVC tube plus half of the diameter of the outer diameter of the pulley. And this, you can see the equation here. So PVC outer diameter plus half of the bearing outer diameter is overall distance of the center of the bolt or pulley to this line. So this is perfect, exact distance that can fit a bearing in the middle. Same with here, the distance of them is fixed, and same with these guys, other holes as well. Let's quickly go through them here. Same formula, just repeated, times 3. Oops, what's happening? Okay. Over here, yeah. I believe it's complete. I am right now finished walking you guys through the design. Maybe this pendulum is left. So pendulum, a full pulley will literally go sit in it with glue. I made it friction fit, but I don't have any pulley to make it absolutely friction fit. We might need to use glue. It sits inside. Let me bring out the picture again. So it's 22 on the outside, that hole also is 22.8, which is perfect. This inner diameter here is my last discussion in the group chat. 8 millimeters in diameter, which it can fit in a M8 bolt. Over here, I made this extremely strong because I hold the weight of the pulley and not the pulley, a pendulum, and the weight you guys are putting on it, and the PCB board and the wiring for the SID board. I made it stick out a little bit so it won't touch anywhere. This would be solid fully. I'm gonna add fillet here to make it more strong on this line. And in M8 bolt will hold it perfectly, so it goes through inside with a nut and 2 washers. The thickness over here from this ring, the thickness of this ring is almost identical to the thickness of this silver part here. The reason I did that, well, it took a lot of effort, but this black part rolls against this, so it should not touch the black part to hold it in place. That's why I made sure this clears as well. It's good that we're using M8 bolt, so it will be fully strong and foolproof. And that's it. This is the whole design. Oh, also the pendulum itself, it is too long to fit in my printer, pretty much any printer that's for consumers. I made this cut, it would hold itself. I also made a, let me see if I can find it. There it is. Let's call it a prototype, but a test prototype, and this is how tight it is. You can still use glue, but this is literally, you can hear the sound of how tight it's gonna be. And you can tell this is that, obviously.